Good evening, virtual audience, and welcome. Thank you for joining us tonight. My name is Kate Bruns, and on behalf of Harvard Bookstore, the Harvard University Division, and the Cap Science Library, I am so excited to welcome you to this event with Sarah Stewart Johnson, presenting her new book, The Sirens of Mars, Searching for Life on Another World, in conversation with Deborah Blum. Tonight's event is the next installment in our Harvard Science Book Talk series. We are so excited to continue the work of bringing the authors of recently published science-related literature to our community during these unprecedented times. Coming up on July 23rd, we will be virtually hosting award-winning scientist and author of Lab Girl, Hope Jahren, in conversation with Barbara Kingsolver. They'll be discussing Hope's latest book, The Story of More, How We Got to Climate Change and Where to Go From Here. Just like always, you can find announcements about upcoming events in this series at harvard.com/events/science, or you can sign up for the bookstore's email newsletter at harvard.com. Additionally, we have a Science Research Public Lecture Series YouTube page where you can see any previous talks that you might have missed. This evening's event is going to conclude with some time for your questions. If you would like to ask Sarah and Deborah something, please go to the Q&A button at the bottom of the screen where you can submit your question. We're going to get through as many as time allows for. Also, once the event begins, I'm going to be posting a link in the chat to purchase tonight's featured book, The Sirens of Mars. All sales through this link support Harvard Bookstore, so a huge thank you for your support. Your purchases and your financial contributions, there will also be a donate link in the chat, make this virtual author series possible, and now more than ever, support the future of a landmark independent bookstore. So thank you to our partners at Harvard University, and thank you to all of you for tuning in and showing up for authors, publishers, indie book selling, and especially for science, because it really matters. Finally, as you might have experienced in virtual gatherings the last few weeks, technical issues can arise, and if they do, we're going to do our best to resolve them quickly. So thank you for your patience and your understanding. And now I would like to turn things over to a special guest who will be introducing our speakers this evening. Peter Gerges is professor of organismic and evolutionary biology at Harvard University, where his lab studies the physiology and biochemistry of deep sea microorganisms. He's also co-director of Harvard's Microbial Sciences Initiative and an adjunct oceanographer in applied ocean physics and engineering at Woods Hole Oceanographic Institution. We are so excited to have him on board tonight. So without further ado, Peter, the virtual podium is yours.
Thank you very much, Kate. It is a real pleasure and treat to be here tonight. And it is my great pleasure to introduce Dr. Sarah Johnson and Ms. Deborah Blum to you. Now, I first met Sarah in 2007 when she was a junior fellow at Harvard University. I was a young assistant professor working on deep sea hydrothermal vents and seeps when Sarah approached me with a project idea that was so audacious that I thought, Sarah, you must be out of your mind. Let's do this. Now, I saw Sarah as a chance to maybe share my resources and maybe impart a bit of knowledge to an early career scientist who was eager, as I was, to tackle some of the toughest questions about the origins of life on Earth. Now, Sarah earned her undergraduate degree from Washington University in St. Louis, as well as a bachelor's and master's degree from the University of Oxford. She went on to earn a doctorate degree from MIT, and then presumably, to avoid the headache of moving, decided to hang around Harvard as a junior fellow. One of Harvard's most prestigious awards for early career scholars. And that's when I met Sarah. And that's when I knew she was destined to change the course of science, and in particular, astrobiology. Now, maybe it was the ceaseless ringing of the bells of Lowell Tower, or maybe it was her determination to advocate for science on the Hill. You know, we may never know. But Sarah served 2 years as a White House policy fellow, and then joined the board of trustees of MIT. Well, now, maybe it was the dreary winters of New England, or maybe it was also her commitment to advancing the search for life on Mars. But Sarah then spent 2 years in the beautiful Pasadena area at the Jet Propulsion Labs. In 2014, Sarah joined the faculty at Georgetown University, where she now leads a research group focused on life detection in some of Earth's most extreme environments. Now, remember when I said I was eager to share some of my resources, maybe impart a bit of knowledge? Well, I think I got it backwards, because you see, NASA recently awarded Sarah a $7 million grant to lead a team of scientists on developing revolutionary new techniques to searching for life beyond Earth. She asked me to join her team, so now I work for Sarah. And it seems that we've come full circle, right, Sarah? But tonight we are here to celebrate another of Dr. Johnson's contributions to the search for life beyond Earth. Sarah's book, The Sirens of Mars, provides us with a backstage view of the search for life on Mars. And it gives us all a glimpse into the processes as well as the challenges of searching for life in our solar system beyond Earth. And frankly, I can think of no one better to tell this story than Sarah. It's also my great pleasure to introduce and to finally meet Ms. Deborah Blum, who is a Pulitzer Prize-winning American science journalist, columnist, and author of 6 books, including the 2018 New York Times notable book, The Poison Squad, which I love, and New York Times bestseller, The Poisoner's Handbook. Her other books include Ghost Hunters, Love at Goon Park, Sex on the Brain, and The Monkey Wars. She's a former president of the National Association of Science Writers, was a member of the governing board of the World Federation of Science Writers, and currently serves on the board of the Council for the Advancement of Science Writing. Blum is a co-editor of the book A Field Guide for Science Writers, and in 2015, she was elected as the 4th director of the Knight Science Journalism Program at MIT, which is a very distinguished honor. Again, I'm a huge fan, so I'm trying hard not to geek out right now. So without any further ado, it is my great pleasure to turn the virtual podium over to Sarah and Deborah. Let's give them a warm virtual welcome. Thank you all.
Thank you so much, Peter. That was amazing. And I'm going to ask you to introduce me and Sarah for the rest of time. So, now I'm going to start segueing us into a conversation. And I want to start by saying I've been a fan since 2014 when I was a guest editor of Best American Science and Nature Writing. And I was trying to pick the essays and stories that would go into that anthology. And there was this amazing essay called O-Rings, which was about Antarctica, risk, human error in science, and the thin, fine glow of human endeavor and the willingness to challenge ourselves. And I thought, who is this writer? And so O-Rings did indeed appear in that anthology of Best American Science and Nature Writing, but I would like to say that I am not surprised, but very delighted to see that same glow in the early reviews of Sarah's books, The Sirens of Mars. And when I go through them, I see the kind of words that I would expect to see, which are vivid, lyrical, and even the word gorgeous. And all of that is true. It's a wonderful book. Now, Sarah, you're a planetary scientist with a $7 million grant. You're an astrobiologist. What decided you to write this book about Mars in particular? And what decided you, more than that, to write it in this way, a book that is both scientific and poetic?
Oh, Deborah, that's such a great question. And thank you both for those amazing words. They're really touching. I can't tell you how much I appreciate it. So this book that I wrote, I never thought I would write a book. The first, that essay that Deborah mentioned is the only thing I'd ever published for an audience before, besides, the sort of stuff in scientific journals. And so I guess I'd always been one of these kids that scribbled things down. I kept a journal when I was little. I've always loved writing. And I think that as I progressed through school, I was in school for a long time, and then just kind of as I started my career, there would be all of these things that just seemed really compelling about the science, and especially about the search for life, this very human endeavor that just would never really find their way onto the pages of scientific journals. And I'd go to lectures and I'd read things and I'd sort of scribble things down kind of at the back of a notebook that I would keep, and all these ideas that just seemed really poignant and evocative. And I don't know, I think that there was part of me that just felt like Mars deserved a sort of different kind of treatment, something that really captured the wonder and the majesty of the whole endeavor. And it wasn't just about the science, but also about kind of this human relationship to the planet. And so I guess those passages kind of came together, and eventually there were chapters, and then there was a manuscript. And so, yeah, so now there's this book out in the world.
So one of the things you just said really resonates for me, and that's a conversation we have in science journalism, which is, can you accurately describe the process of science if you don't acknowledge that it's a human endeavor, right? That if you as a science journalist are reporting on science and somehow, and I think in our past tended to do this, describe scientists as somehow above human, cold and clinical and never making errors and smarter than the rest of us, then you fail, right, to describe what science really is. And one of the things that I find so fascinating about your book is the way that you acknowledge the sort of humanness of science itself, and both the times where you have brilliant insights and the times where you have what I'm going to call at this moment brilliant errors, right? And I think in telling the story of science, whether it be Mars or any other story of science, that's an amazingly accurate description of what it is. You also have a great description of the moment you settled on or sort of started to focus on what I think of as biology against the odds, which is another way to say astrobiology. And there's this wonderful discovery of a fern under a rock, and you describe it both as defiant and impossibly triumphant, which I really love that description. But that's a description really of a moment when you are farther along in your scientific career and sort of figuring out the focus of where you're going to go. But I wonder, for those people who haven't read the book, if you can talk a little bit more about your backstory, your family backstory, what sort of brought you into this particular area of science at all.
Oh, sure. So I grew up in Kentucky with my parents and my sister, and I guess there were elements.
Eastern or Western? My family's from Western Kentucky. So.
Yeah, Central Kentucky.
Oh,
so,
okay.
And spent a lot of time in Eastern Kentucky growing up as well too. My dad was from there, and a lot of my relatives live out there. So we'd spend a lot of summers and trips. But Kentucky's just the most wonderful state. But anyway, so I grew up here, and there were elements. I think there really were kind of like elements of science and elements of even planetary science, now that I look back with the benefit of hindsight, that I can see in my childhood. My dad subscribed to Astronomy magazine, and he had a really sort of scientific mind, and my mother was just this incredibly insatiably curious person. And and even as a child, we'd be in the Appalachian Mountains at times, and we'd see these big road cuts, and my father was so interested in the layers and how they all came together, and we'd go look at these things together. And I think sometimes I thought, like, why am I getting dragged out to do all of this with my nerdy father? but like, I went off to college when I was 18, and all these things were really gravitating. They were coming back to me as things that I was finding like this very deeply ingrained sort of interest in. And Mars in particular, I think, came from the fact that when I was a freshman in college, I met this professor, this man named Ray Arvidson. He was a planetary scientist at the college I went to in Missouri, and he was he was doing work on Mars, and he let me join his laboratory when I was just 18 years old, and I got to start doing research on data, like real data. And it just felt like I was discovering things, and I was creating knowledge in this way that was just so compelling and interesting to me as such a young person. And he also took me on some of these trips. So the trip that you described was going down to Hawaii. So he took a class out there, this whole class of kids, to just go study volcanoes. And there was this place that we went to, Mauna Kea, like way high above the tree line, 14,000 feet, the kind of place you have to stop and acclimate for hours before you go up to the top, because it's 40% less oxygen, and the whole world, once you get there, it just doesn't seem like our world at all, because it's gray and dark, and they're just, the rocks are, it's just like a kind of crystallized bruise, I think is how I describe it in the book. And then there was just this little splash of life, like just against all the odds, where life, there shouldn't be any life. And it was just this moment of just like, it kind of felt like I was out in the middle of outer space. And then all of a sudden there was this living organism. And even if it was the smallest little thing in the middle of this tremendous void, it did feel like really triumphant. And I think that there was something in that moment that really made me become a planetary scientist and astrobiologist, kind of started to make sense to me.
I kind of love those moments, right, that turn you in one direction or another. One of the things I'd like to ask you about, and if you look at the history of, I'm just going to pick Mars, but if you look at the history of Mars exploration, going back into the 19th century, you will see a litany of influential men. And yet, one of the things that strikes me when I read your book is that here you are, you're a female scientist in an area of sciences that dominated by men. You have, and you give a shout out to your mentor at MIT, Maria Zuber. And I'd like to just ask you, it's a little bit of a side trip, but I think it's really important to talk about this. And I think it's important, on all kinds of ways, the challenges of being a female researcher, being a working parent. And I think too, and I've thought about this as someone who came into science writing very early, not science, but science writing when there were very few women in science, the importance of having female models and role models in the profession. And I wish you would just explore those issues a little bit.
Oh, sure. Yeah, I'd be lying, I think, if I said it was sort of easy being a working parent. And there really aren't as many women in planetary science as I'd hope there'd be. They still only comprise 15% of NASA's missions teams. So we've got a fair amount of work still left to do. But it sort of breaks my heart when I think about the fact that if I had been born 50 years ago, I wouldn't have been able to do any of the things that I've done today. And that's the same for my colleagues, it's the same for my students. And I just can't imagine a world, like, how can we tackle these really deep, enormous questions about the universe if we're not drawing on the brightest minds? And that's in all areas of science. How do we get over a global pandemic if we're not really drawing on, people, everyone from the entire population? And I just think it's really critically important that, everybody feels welcome and is welcomed into science. And I think one thing with women in science, I think the more women there, it'll just sort of beget more and more women. I mean, I just think about the fact, so you mentioned Maria, and so Maria is a professor of planetary science at MIT, and she was the very first woman to ever lead a competitive planetary science mission out into space, and she was the first female department head of a science department at MIT. And she was also the first woman I ever heard give a planetary science talk when I was in college. And I think that ever since that moment, she's been like my total hero. And I still just cannot believe that I had the chance to study with her. She was my PhD advisor, and she was just at the pinnacle of the field. And, she just pulled back the curtain and let me see how science could be done at this just incredibly high level. And it was so inspirational. It was so inspirational to see her, doing all of these things that I kind of dreamed about doing. But there she was, like the living, breathing example. It was just really incredible for me.
And I think that's a great example of how important it is to have, I mean, the sort of cliche term is role models, but to be able to look up in the hierarchy of your profession and see that there are people like you, right, who are actually succeeding and adding really good insights. I agree with you about the diversity of perspectives, and I see that coming up in some of the questions that I'm looking at. So I want to come back to that issue when we open up the Q&A. Just briefly, any particular challenges as a working parent?
Oh, Legion, so many challenges. Oh, so I've got 2 little kids, and they're still pretty little. And so I guess I'm good at waking up in the middle of the night, working on deadlines. I've gotten used to sleeping when I can. Yeah, I can think of one time, even just as one example of this, like, you've got so many demands, kind of running a research lab, and you really want to do your very, very best there. And then you can't miss these moments with like little kids, because it's like a moment, and then they're grown up, you have to take advantage of every second you have with them. But yeah, sometimes those things kind of collide, and I think it's been tricky because I really don't like compromising. I don't like doing things, kind of half-heartedly. But just, I guess it was the summer before last, I think this is just one example of kind of how things kind of came to a head with my son was about to go into kindergarten, my oldest child, and we had this babysitting set up for him. We had childcare, and my husband had this like crazy week at work, and I was planning to lead an expedition to Iceland, taking along a couple of students, meeting up with 2 important colleagues, and we were going to test these new technologies out in just the volcanic highlands in this really remote part of the country where the forces of like volcanism and glaciers came together, and it was a great analog for Mars. And anyway, I've been looking forward to this trip for weeks, and then our childcare fell through just completely, just 3 days before I was supposed to leave. And it was one of these things where I thought I was going to have to cancel the expedition, or my husband was going to have to cancel all this really important stuff at work. And we just fell into this like crisis. And I don't know, this is another time it's great to have kind of women colleagues and other folks, because I called up some other working moms, some friends at Georgetown, and everybody was really supportive, and they just said, just take him. And so I just took him. And it was this moment where I just was so worried that it was going to compromise things, but it ended up being, one of the best times I've ever had. I just bought him a plane ticket, and I strapped his little booster seat into the back of a 4x4 Toyota Hilux. And my friend Kate and I, we drove these trucks off-road for a few hours up into the mountains. And and I got lucky in a lot of ways. We had beautiful weather, and he was on extraordinarily good behavior. I think he was just so excited to be part of the team, and my students just were so sweet to him, and my colleagues were so understanding, and everything worked. I mean, there are a lot of ways it might not have worked out so perfectly, but I guess, I don't know, I feel like I've been sort of able to wiggle through the last few years, at least trying to balance it all, but I'm not sure it's been particularly easy. But it's just kind of too bad that, for a lot of female academics, this kind of period when you're pre-tenure is such a crunch time. And that's also a time when a lot of female academics have young kids. So I wish that we could do something about that.
It is, and I like your story. I mean, I hope we're getting more enlightened about this, and the basic acceptance that you can take your kids and it's not going to compromise things is, I think, a really important point. And so this allows me to segue into the issue of relationships. In many ways, to me, your book is a story of relationships. It's a story of our human relationship with what I think of as an inanimate object. It's we love Mars. We fantasize about Mars. We obsess about Mars. It doesn't feel that way about us. It doesn't love us back. It has no interest in us at all. And yet, so how do you explain, of all the planets, the other, I guess now that we've discarded Pluto.
Oh, poor Pluto.
There are half a dozen planets in the solar system besides Mars and us. Why Mars, right? Why, if we're going to fix on a planet and, have a love affair with a planet, why would it be Mars?
Oh, yes. Well, I think that to some degree, we've got a love affair with all the planets. They're all just incredibly complex, fascinating, beguiling worlds that we just totally want to explore and want to know better. I mean, I guess even back in ancient times, there did seem to be this kind of recognition that, okay, of course, there were these 5 dots that seemed different from the other dots in the night sky. There were all the fixed stars, and then there were these 5 wanderers that kind of did their own thing. And one of these was bright red, and it was the only one with a real distinctive color. And so I think that was maybe started off the love affair with what is this color? And then there was also this really curious, weird thing that Mars did. So, even like the Mesopotamians would look up at the sky, and Mars would sort of move east against the backdrop of the fixed stars. And it would do so night after night after night. But then every couple of years, for 60 to 80 days, it would just sort of backpedal against the zodiac, and it would go west. And then about, 10 weeks later, it would resume its normal course, and it would effectively trace out this loop. And sometimes it was a little loop, and sometimes it was a big loop. And it was just so perplexing. And there's this great quote by Plato. He had been looking up, and he had said, what could these be? I mean, these planets must have souls, because what else could, these retrograde acts be if not just expressions of free will? And so I think that we had this early fascination with the planet. And then, especially since the dawn of the space age, as we've gotten to know these worlds better, one reason that Mars is really continue to be a place that we spend a lot of time and resources, and there's a lot of fascination, is really this idea of the possibility of life there. And it's not the only place that we think about in the solar system. There are other potential targets from an astrobiology perspective, but Mars, was the planet, and we found all these exoplanets. We've been looking deep into the night, and we still have never found a planet that's as similar to the Earth as Mars. And especially back early in our histories, these 2 planets were much, much more similar back at the time life was getting started here. So Mars was warm and wet, kind of at least episodically, and it had all the sort of essential ingredients for life. We've gone back and looking at the chemicals and the minerals and all of the investigations that we've done of the surface environment. We know that these ancient landforms, these ancient environments could have supported life the way life started here, life as we know it. And so I think that's really propelled a lot of searching. And, it's still a place that we can access easily, and we can do really sophisticated science on the surface. We can land these rovers that are a metric ton in weight, these mobile science laboratories. And we've really found out amazing things, we've just had the last 20 years of exploration, the planets kind of burst into technicolor focus. And and I just think it's a really exciting time for Mars exploration. But I do feel maybe it's that core idea that we might find life on Mars that makes it so scientifically rich and fulfilling to go after.
Actually, isn't one of the brilliant questions I had written down, but listening to you made me think about it. Do you think that Mars also has inspired our search for, I mean, sometimes people use the term extremophiles, but our realization that life exists in these impossible situations on our own planet?
Yes. Well, and I think that there was this kind of historical period, where there had been a number of people that kind of trained up in the 1970s. We had all these Mars missions starting in 1965 through the late 70s. And then the last, feeble little radio wave oscillated from, the surface of Mars back to Earth in 1982 from the Viking lander. And then we didn't have Mars missions again until the late 1990s. And there was this period, I think in the 1980s in particular, and early 90s, where exobiology kind of got rethought of and reformulated as astrobiology, which would actually be a science that wasn't just looking out, but also included the Earth and really included this idea of trying to figure out what are the limits of life and what is life. And, we were making all these really amazing discoveries at the same time, different domains of microbes that we didn't even know existed before. And, we were finding life that was just existing in places that we thought had to be sterile, you know, that we never would have conceived of life, you know, down in these like deep ocean vents that Pete studies, you know, where you're just at these impossible pressures and it's incredibly dark. And then you have thriving microbial communities, you know, and not just microbes at these hydrothermal vents. And, you know, we would look into places like Antarctica, which, you know, people long thought parts of Antarctica were sterile, and they aren't, you know, like we'd be finding that, you know, we just weren't looking in the right way. You know, and we found these really fundamental things about biology that we discovered, you know, like this idea that like a lot of like the vast majority of the microbes here on our planet won't grow in a laboratory. And for the longest time, we just thought, well, of course you can culture everything. You just give it some nutrients and it'll grow. And we even designed some life detection experiments on Mars around this kind of idea that you can just kind of have a chicken soup and things will grow up. And, you know, now we know more about biology and we understand that there's like a lot that we just can't grow in our little laboratories because, you know, they don't like a lot of nutrients, or they grow on very, very slow timescales, or it's just really hard to take them out of their environment.
I kind of love the idea that studying, at least the idea of life on Mars, helped us better understand life on Earth. Yes. But I want to raise another issue, and it's one that you raised in your book that I also kind of liked, and that's the inspirational or aspirational quality of this. And I think of it especially, or I was thinking of it, and I wish you would briefly discuss William Pickering in World War I. And partly because, you know, for me, he's a good example of someone looking away at a time when the Earth is in a moment, or human society is in a moment of deep stress, as in World War I, and finding sort of comfort and peace in the promise of better times, you know, across the miles. And I think, and I wonder, if there's something about that too, as we work our way through a very challenging pandemic, if there's sort of hope or inspiration in the idea of looking outside the minute into, you know, life as you describe it, defiant and triumphant.
Yeah, well, I guess the backstory there for folks is there was this man named William Pickering. He had been associated with Percival Lowell, who was this kind of, you know, big name in Mars. He had come up with this canal theory for the surface of Mars, and Pickering sort of, I guess he just kind of walked to his own drumbeat, you know, like he had been a person that had loved mountains his whole life, a real wilderness guy. He had traveled a ton, and he had gone down to this plateau in Jamaica, actually using funds from Harvard College. You know, like they had gotten some, I guess, some funds to set up a remote observatory down in this place in Jamaica. And he is this big proponent of this idea that you've got to go where the scene is best, you know, and in these industrial northeastern cities, you can't see diddly from an astronomical perspective, you know, because of the Industrial Revolution and all this pollution, and the skies were just really bad. So you got to go out into these wilderness places if you want to see the planets. But he started doing this thing that just really has always struck me as very poignant. You know, it was the eve of World War I, and he's just down there by himself, and he's observing Mars, and he's making these beautiful sketches and writing notes about it, and then he decides to start writing weather reports from Mars. And every month he would send these weather reports back to the United States, and he kind of trot into town on one of his horses. He called them Jupiter and Saturn. And he would cable them back, and they would detail these like amazing things, what he imagined to be like the greening of the southern Maria, and these high sweeping cumulus clouds, and these gargantuan floods that were coming down from the northern hemisphere. And in Mars, he saw just a wilderness, like just this refuge that was free from suffering, and it was free from injustice, and all these brutalities were amassing across Europe. And he looked at this planet, and I think it was just a reflection of what he most longed for, and what a lot of humans at that point most longed for kind of deepest in their hearts, like a place where, you know, there wasn't such office, you know, and I don't think that we should look at Mars, you know, as an escape from like the very serious problems in our own world that absolutely need to be dealt with. But I do think that there's something very, very poignant in that sort of sentiment.
So I have like pages of more questions because your book is so rich and so amazing. I want to close our part of it and then open it up to the Q&A. We've already got a number of questions here that I'm looking at. We have a number of missions to Mars this month in particular. And I'm curious if, you know, you want to give us your perspective on those, and if there's, you know, a point that that you really think is important and as a kind of takeaway from the way you tell the story of Mars and scientific research.
Oh, sure. Okay, so 2 questions there. The first one is like, this is so exciting this month. So Mars and Earth only line up on the same side of the sun every 26 months, which is why we got those retrograde things every 2 years. And this is one of those moments where they're swinging close to one another. And that's when we can launch missions. And so there are 3 missions that are going. There's one actually just in 2 days. It was supposed to launch today, but they had some cloudy skies over in Japan. But the United Arab Emirates has put together their very first Mars mission, and they're launching it from Japan in collaboration there. But it's the most amazing little probe. It's called HOPE, the mission. It's the Emirates Mars mission, but the probe is called HOPE. And it's really incredible. They didn't even have a space agency 6 years ago, and now they're going to Mars with this orbital mission. And then the Chinese are also launching a mission. It's called Tianwen-1. It's the name is translated as Questions to Heaven, and it's an orbiter, a lander, and a rover. And that'll be, you know, in the coming days. And then on July 30th, the window is going to open for the Perseverance rover, which is NASA. It's a big mission the size of a Mini Cooper, and you know, it's kicking off this breathtakingly ambitious campaign by NASA to collect samples from Mars and bring them back to Earth. And it will actually require 3 different missions, you know, a Fetch rover to go pick these samples up and another mission to swoop them out of orbit and bring them home. But that'll be done sort of with international cooperation with the Europeans and with others. And so it's just a really exciting moment. These missions will arrive in the spring. Perseverance will touch down on the 18th of February. It's a Thursday, so you can mark your calendars now. No matter when it launches, it'll be that Thursday. So it's just a really exciting time. You know, our last rover from NASA was in 2012, so it's a big moment for the Mars community. And there's something. Oh, your other question, Deborah. Oh, just like a takeaway. Oh, sure. That's a great question too. So I think one thing that has been great about spending a lot of time thinking on these very large scales and thinking about this planet that's like, you know, millions of miles away, 100 million miles away, and thinking about geologic time and these vast time scales, you know, like looking at Mars, you know, billions of years into its past as well as now. I think there's something about discipline that has been great in terms of, you know, kind of understanding just how very brief our moment here is. You know, we each have one of these kind of shining moments here on Earth, and, you know, it's just gonna be gone so quickly. And like, I just think it's just so important that we each, you know, try to struggle and wrestle with these big questions, and that we make the very most of our short time here on this small rocky planet in this, you know, kind of nondescript corner of the galaxy, you know, to really make the very most of this time.
I like that a lot. I've got already 11 questions in the queue, and most of them apply to Mars and are fairly science focused. I'm going to take the one that isn't, which relates early to the point you raised earlier about diversity in science first, and then really focus on the science and the Mars. So this question is, what do you think your profession is doing to open astronomy to Black, Indigenous, and people of color?
Yes, no, that's an absolutely critical question, and it is something that we need to do so much more of. You know, I was talking about 15% of participation on planetary missions are women. You know, it's less than 1%, I would guess, of, you know, for Blacks and Hispanics and Indigenous people. Like, it's just, you know, I go to these conferences and it breaks my heart to, you know, sort of look around the room and see so little diversity. You know, and there are training programs, there are lots of, you know, different things that NASA has been trying to do, but I just think it's incumbent on all of us, like every single person in planetary science and astronomy, to like recognize that we, again, are just not going to be able to ask these big questions if we don't have full participation from our entire population. And I'm very much, you know, with the questioner on this, because there are just so few opportunities, you know, and I've got good friends that are in the field that are just, you know, like, I know some of the things that they've dealt with, and like comments that people make, and ways that they just feel like they just don't belong. And it's just awful. Like, it's just really, really awful. Right. And a huge problem.
And not just in planetary science, but across society. I think we all want to tackle that. I'm going to briefly do the one other question because I don't want to miss it. Hi, this is from Claire, age 8. I want to be the first person on Mars. Do you have any suggestions? Yes. I love that. Do you have any suggestions for me to be the first person on Mars? And what books did you read when you were 8?
Oh, Claire, that's such a good question. Thank you so much for staying up and tuning into this talk. I really appreciate it. So what was I reading when I was 8? Well, okay, first of all, some advice about becoming an astronaut and heading off to Mars. I just think that would be wonderful. So, you know, astronauts come from all walks of life, and you can go, and a lot of astronauts do go through, and they get a scientific degree. And so, but it doesn't have to be, you know, astronomy or planetary science. It could be mathematics or physics or chemistry or biology. You know, there's so many different ways that you could come into this, you know, in terms of what you study. But the thing I think that's most important is you find something that you're really passionate about, you know, something that really, really like sparks your energy and makes you feel like, oh, if this is my job, I'll never work a day in my life. I think that would be really good. And you know, the other thing is, just don't give up. Like, we need you to become an astronaut and to join the ranks of scientists. And I think that you just believe in yourself, and, you know, just, you know, find friends that like science and mentors, and just go for it. I think that would be really great. And I'm trying to think of books that I was reading. You know, I love James and the Giant Peach, but I'm not sure I was actually reading that when I was 8 years old. Maybe I was not so sophisticated back when I was 8. That might have been more like 10 or 11.
It's a good book, though. So I'm going to shift us over into science. And I actually have a question that says, sure. I would love to hear more about the status of astrobiology today, future prospects for the field, and the speaker's own research. And from there, we're going to launch into a whole lot of questions about Mars and life.
Sure. So the state of astrobiology, and then some stuff about my own research. That was the gist of it. Mm-hmm. Yeah. So astrobiology, I feel like, is really coming along as a discipline. There's sort of dedicated conferences now, and folks that, you know, dedicate astrobiology journal, and there are even starting to be some PhD certificates and PhD programs in astrobiology, which is great, because it's really kind of sitting at the nexus of lots of different disciplines. Were you trying to break it, Deborah? Oh yeah. Okay. No, and then okay. And then some stuff, I think there were some questions about my research. Is that the other part of it? You know, like, what am I doing as an astrobiologist? Sure, that's a good one too. So I run this biosignatures lab at Georgetown. And so biosignatures are traces of life, and we're trying to figure out how we can find them in planetary environments. And so the lab kind of draws on organic geochemistry and molecular biology, and we do a lot of field work in analog environments, places places that bear relevant similarities to Mars and these planetary targets. And so we go off to, the Atacama Desert or the dry valleys of Antarctica, and we test these kinds of approaches that we could use for life detection. And we're also involved in kind of analyzing some data from current spacecraft and also designing tools and techniques for looking for, and building instruments for future missions. And one of the projects that I'm most excited about right now is one that I've been working on with Pete, who was doing those very kind introductions. And we've joined forces with lots of other colleagues at institutions around the country and even across the world. We've got folks in Glasgow and in Canada, but we've been trying to figure out how to detect life, not just life as we know it, but also this idea of life as we don't know it. So types of life that could have like a different underlying biochemistry or different type of molecular framework, life that might not even be carbon-based, so trying to really expand out what we think of life and be more inclusive, not just looking at, the really telltale molecular fossils that we find associated with terrestrial life, but looking for things like chemical complexity or unexpected accumulations of elements or isotopes or evidence of energy transfer, things that, wouldn't require the very, very specific biochemistry that we've got here on Earth.
And that leads me right into a question. I haven't been using people's names, but I'm going to start using first names. Helen, if there is life found on Mars, what do you anticipate it may be like? What type of life do you think it might resemble?
Oh, I like that question as well. So I don't think we're gonna find, little green men, little blobby aliens. I think that if we find, my best guess is if we find life on Mars, that it'll be pretty simple and pretty primitive. Like it'll be kind of in this single-celled microbial form, and it'll probably be down in the subsurface, which is where, more than 50% of our biomass here on Earth is held like in the subsurface in microbial form. And I think that because the surface environment of Mars, there's a lot of radiation, it's a really punishing place. There's no magnetic field protecting the surface any longer. And so I think it'd be sort of harder for molecules to stay together up there at the surface. And so if I was a little microbe on Mars, I would retreat down underground. And of course, for the majority of Earth history, our life was also just simple and microbial. And so I think that's just sort of my guess. There's a possibility that if we find life on Mars, it could be ancestrally related to life on Earth. We just kind of caught it from the next planet over. And I think that could be incredibly exciting to find. There were lots of rocks exchanged between the two planets, especially early in our histories around the time life was getting started here. And, that would give us a chance to kind of replay the tape of evolution, rerun that great experiment and see what turns out. But the thing that, me personally, that I get most excited about is this idea of a separate genesis, a type of life that we've never seen before, and that's really different from the life that we have here. And the reason I say that is, we've got this one data point for science. All the life that we know of is the same stuff. It's DNA-based, it's carbon-based, it's like us and everything else alive around us. It's all essentially the same life. And just the incredible advances that we would make if we just had a second data point, a second data point to really understand the constitutional sort of nature of life and understand maybe biology is just a consequence of energetic systems. Maybe it's an emergent property of planets. And especially if we found life just right here in our solar system, like this near neighbor, I think that would just really be, indicative or suggestive that the whole universe would be teeming with life. If it happened twice, if that kind of something from nothing, if that happened more than once, just here in our own little corner of space, I think that could be really, really promising.
Which kind of leads me to a question by Bion. How much do you expect the field of biology to change if life is found on Mars?
I actually think it could be a huge, so biology has been changing, those of you that are coming from the field of biology know this, but if you look at the past few decades, it has been this breathtaking pace. You know, it's this breakneck pace. I mean, discovery after discovery. Like we've discovered so many things, but still there's this part of me that feels like there's a way that you could see biology as largely kind of a descriptive science, you know, like we don't understand kind of fundamental principles of biology, again, because we're sort of limited by that one data point. And I just think it would be better than anything any sort of pharmaceutical company could come up with, you know, this idea of what life is. And it sort of reminds me, there's a philosopher that's at University of Colorado who, you know, she sort of has this idea that you can't even define life, that's premature to even define life. Like it was premature to even define water before we understood chemistry, before we knew that it was like hydrogen atoms and oxygen atoms. I mean, you could kind of describe it. You could say, oh, it's kind of wet and it's clear and these things, but you had to understand the like sort of underlying principles before you could even really know what it was you were dealing with. And I think there's some merit there, you know, like I think that we just would stand to learn so very much from a different type of biology.
I have a couple of questions that have a slight overlap from David and from Niels, and I'm going to read Niels. Do you worry that the stressing the search for life on Mars so much that planetary scientists are setting us up for disappointment? Is this not a concern? It seems like 95% of the Mars exploration program must justify its existence to taxpayers in terms of the search for habitability.
Oh, that is such a great question. And it's not crazy. Like there was this moment, you know, when I talked about that 20 years when we had no Mars missions, and it followed the Viking landers. And in the lead up to the Viking landers, it was this moment where it was going to be the greatest experiment in the history of science. We were going to touch down and we were going to look for life on the surface of Mars. And there was like an incredible hype around it. And we had wonderful Carl Sagan, who was sort of out there describing all these possibilities. You know, we might have, you know, something walk by, we could use a nightlight on these landers. What if life on Mars is nocturnal? And what if it's not small, but huge? You know, what if there's silicon eating giraffes munching on the lander? You know, these really imaginative, exciting ideas. And like in the end, like those experiments, they came up dry. And I mean, we sort of understand a lot more about, you know, for instance, why we didn't find any evidence of the building blocks or organic molecules at that moment in time. But I think there was like a huge amount of disappointment. And I do think that this sense that, oh, we tried that, there's no life, we're done, you know, did really impact the Mars exploration program. So a couple thoughts there. Like I do feel like a lot of the Mars program is driven by astrobiology, but that's not the only thing that drives it. You know, this was a planet that was so very much like our own, that took this very different planetary path, and sort of understanding Mars from a climate history perspective, understanding its environmental history, kind of what happened to it and how that all went together, I think is really huge. I also think that Mars, this surface that's ancient, and so much of our own ancient past here on the Earth has been swallowed back inside through the churn of plate tectonics. You know, our history is irrevocably lost. Like it has been erased, but Mars preserves a record of what our early solar system was like. And so even if there's no life there, I think that is tremendously important to understanding sort of how planets form and the physical science there. But I think that, you know, if we do get to a point where there's no life, and I'm not ready to concede that, because I still feel like we've barely scratched the surface. We've landed at a few places on the surface, you know, a couple of spots. We've done a few experiments, but we haven't, for instance, ever drilled down into the subsurface, which I think would be the best abode for extant life, at least. But if we do get to that point, like, I don't think that the search will end, you know, like I think that there are other places that we will continue to look, you know, these moons of Jupiter and Saturn, these different worlds, you know, Titan, for example, this moon of Saturn that has completely different chemistry than the sort of water-based solvent that we have here on Earth. You know, you've got hydrocarbon rains and ethane and methane lakes and seas, you know, just a place where a total totally different kind of life might have taken hold. Like, I think that we would continue to search, and NASA would continue to press on out into, you know, the further reaches of the solar system.
I have a couple of pragmatic questions. One of them, I'm going to combine two questions. This is from David and from Mark about settling Mars. You know, could Mars be the next Earth 2.0? And what does Sarah think about Elon Musk's grand plans to colonize Mars? Mars be preserved as it is, left to the Martian microbes if they exist, or is our destiny, manifest destiny, I guess, to make Mars humanity's second planet?
Yes. Oh, I like that question as well. And so that's actually a famous quote for those of you guys that don't know, from Carl Sagan. You know, kind of, he had said that if we find indigenous biology on Mars, then Mars should be left for the Martians, and that it should be, you know, not colonized, that it should be its own sort of planet, like a massive national reserve. And you know what's interesting, and something I've spent a lot of time recently thinking about is that, you know, there is this push for human exploration, and you know, the gap between the technology, I think, before Sputnik, when we had nothing, to putting people on the moon, that was 12 years of technological development. And I think that the gap now between sort of the technology we have today and what it would take to put people on Mars is a smaller one. But that's not to say there aren't tremendous hurdles and tremendous challenges that we would still have to overcome to actually technically make that feasible and possible. But I think that the stage is set for kind of rapid progress on the human space exploration front if we decide to make it. And I think there's some things that are really changing the way we explore space. There are a whole lot of other players now that are joining into space exploration. We could potentially see another space race with, say, China, you know, which is coming on in a very, very big way, exploring Mars and pushing toward, you know, all kinds of human exploration efforts as well. And of course, we do have this kind of disruptive factor of these private companies. You know, Elon Musk says that we're going to send 1 million people to Mars, you know, on 1,000 spaceships. And, you know, that seems like a lot of people. That's a lot of people. And you know, and as an astrobiologist, you know, that's really interested in the science, it's a little hard, right? You know, we're big bags of biology. We're sloughing off cells left and right. You know, it's this thing where, you know, even when we look back into the ancient rock record here on Earth, like we have this overprinting of modern biology that makes it really hard to detect and sort of uncode what's happening, like in those ancient samples. And so what I've been thinking about is this fact that I think that there will come a point where human exploration does happen. And I think that it's not impossible for it to be sort of hand in hand with scientific exploration. And I think that there are ways that, you know, still, no matter, we've made all these amazing computers and there's nothing like the human mind. We've never invented anything sort of as quick and amazing as that. But like, I feel like there's something of a closing window in some ways. You know, we have this period now and maybe the next decade or two of exploration where we do kind of have this pristine planet and we can go after it in this really rigorous way with these, you know, very sophisticated spacecraft. And so I've spent a lot of time kind of thinking about like how we can really maximize that. But I do think that there's a way that, you know, we could have, you know, human exploration sort of going hand in hand with the science. And I'd really love to see the science leading that. And it may be sort of a human astronaut that, you know, is the one that would actually discover or find life on the planet's surface.
So the next question, and I'm going to try, we've only got a couple more minutes. So, you know, and unfortunately, this is a slightly complicated question asked by two people, Fatima and Harvey. Has to do with being a scientist who writes books.
Oh, okay.
What is your advice to scientists who want to both do research and write books? And the conventional wisdom is that assistant professors shouldn't write books, but concentrate on publishing papers and, you know, the standard journals. What moved you to write a book? Do you think it'll help or hurt? Do you have any advice for scientists who aspire to follow in your footsteps?
Oh gosh. Oh yes. Well, I had this very fortunate thing happen to me where I got tenure a few weeks ago before this book came out. So I guess I'm sort of safe. So if everyone hates it and thinks that it completely undermines my scientific credibility to write a popular book, then I guess they at least can't take my job away. And I mean, I think there is something valid to that concern, you know, like I did have people like advisors along the way that were saying, you know, don't do this until you have tenure. But there's also this part of me that feels like, you know, wait till age X to like start living your life the way you want to live it. And that's hard too, you know, and when I think about like this book, like, you know, it was written in these little pockets of time. You know, the idea for it really began when I was in a postdoc at Harvard. I was just like this really expansive, wonderful program. And I was just thinking in new ways about everything that I was studying. And that's kind of where the idea, but I mean, that was ages ago. And so it's taken a long time to do it because I have been really focused on research. But I think that, you know, like, I guess it's just, I write, like, that's kind of what I do. Like, I don't really play tennis or have another hobby, you know, like I write and it's what I love to do. And I think it's important to sort of be able to feel like, especially if you're going to go into science, that you can bring your whole self to it, you know, that it's not just, you know, put your head down, eat your vegetables, you know, do it in this one particular way that we say you have to do it. Like, I think that it's really important that people can just, you know, show up with their whole selves and bring their whole selves into what they're doing.
That is a wonderful closing thought, Sarah, and I think you're absolutely right. You reminded me, my editor at Penguin Press always says to me, the fact is that writers have to write, right? You don't just turn it off.
Yeah. And I think just one more quick thing. I think it will honestly, like, if you're thinking, especially for science writers that are writing about the science they're doing or the science that they love, I think it makes you a better scientist. Like, I think being able to engage with it in a way that, you know, sort of brings its complexity out in explainable terms, or like, you know, really wrestling with those kind of bigger questions and connecting it up to these different things. I really do think it will make you a better scientist. And if it's like part of your heart and part of who you are, I think you should just pursue that. I think it's really important.
I love that. And we have not gotten to every one of the amazing questions that I see here, but I do want to say to those of you whose questions didn't get answered, so many of them are actually, you'll find if you read Sarah's book. So not to be a total, you know, buy Sarah's book, but buy Sarah's book. It's wonderful. And thank you so much.
Well, and you guys, you could also find my email. It's just sarah.johnson@georgetown.edu. You can shoot me a question if you've got one. It's also on the Georgetown website.
Say that one more time, Sarah.
Sarah.johnson@georgetown.edu.
Thank you.
And that in the chat, actually. Sarah.johnson@georgetown.edu. How's that look?
Oh, that's perfect. Yes, there it is.
Okay, do you guys have any other closing thoughts before I wrap up your wonderful discussion? This was so great to be a part of and to witness.
I would like to turn the stage over to Sarah for the closing remarks. This is
closing remarks. Oh, I put
you on the spot.
I am so tremendously grateful. Like, this is so great. My parents are watching and you guys said such nice things about me. This is so great. Thank you. And seriously, thank you for everybody for tuning in. Like, it's just so exciting to be able to talk about the stuff I love with everybody. And I just really appreciate it.
Well, thank you to both of you for your riveting discussion. And thank you also to everyone for spending your evening with us. Please feel free to learn more about the book and purchase the Sirens of Mars on harvard.com. I've put it in the chat, but the chat's going to disappear right after I end the broadcast, so you can always look on our website as well. So on behalf of Harvard Bookstore, the Harvard Division of Science, and the Cabot Science Library, all here in Cambridge, Massachusetts, have a good night, everyone. Please keep reading and please stay well.
Thank you.